Alrighty guys, welcome back to Michelle's version of calculus, and today we have unit 1.12, confirming continuity over an interval. And an important factor and things to look for with confirming continuity over an interval is you're going to be doing a lot of finding the domain of stuff. And here are three little scenarios to watch out for when you're trying to find the restriction of a domain. Alright, so let's do for scenario 1, green. First scenario, of course, we have rational expressions. As we learned before, ooh, that's not what I wanted. Alrighty. As we learned before, rational expressions, or just in general, your denominator should never equal 0. It should not be 0 because you'll have an undefined function, which is not what we want. So whenever we do this, we set the denominator equal to 0, and then we learn that x cannot be equal to 2. Alright, so that's something to look for. Our second scenario, which we'll do, let's go red, make this a little bit skinnier. Second scenario in red, of course, is radicals or square roots. And we know that under a radical, you cannot have a negative number because you can't take the square root of a negative number. So in this scenario, we know that x is going to have to be greater than, let's do the math real quick. 6x minus 12 equals 0. We'll send it over, 6x 12 divided by 6 divided by 6. So yeah, x is gonna have to be greater than or equal to 2. Yeah, greater than or equal to 2. It can be, again, you can take the square root of a 0, you just can't take the square root of a negative number. And then with natural logs, the case of natural log we have to keep out for is that you cannot take log of a negative or a 0, which is very important to do. So whatever you do, this right here, this 3x plus 2 is going to always have to be greater than 0. All right. So where is this function continuous? We're going to do a little practice problem over here. All right. So one thing I recommend you do with these kind of problems is go ahead and draw yourself a little number line. I know it helps me a lot. Something that my lovely teacher taught me. So I'm going to draw us a little number line here that's going to kind of represent this cute little function we have. So we have our number 0, 3. All right. So basically for this first one, it's saying when x is less than or equal to 0, that's our function. So we're going to just put this first function over here. So, excuse me, x squared minus 2x minus 1 over 7. That's basically over here, from here all the way to here. All right. So now for this middle ground over here, this middle section. Oof, I don't know why I did that. Oh my goodness. Okay. Oof. For this middle section over here. Wow, this is all glitching. Cool. This is not doing too good, so sorry about that. Okay, now actually for this middle section over here, we have 0 is less than 0, x is greater than 0, and x is less than or equal to 3. So that means this middle interval is going to be this middle one right here. So 3, let's just make that what it is, 3 over x minus 7. All right, perfect. And then for anything x is greater than 3, it's going to be this right here, 7x minus 15 over 4x minus 20. All right, and remember the stuff from last video to figure out where something is continuous. So first thing first over here, we're trying to find the lim as f of x approaches 0. Cut that out, Michelle. All right, so we're going to go ahead and evaluate for the lim of said f of x as x approaches 3. All right, we're going to go ahead and evaluate that. So we have 3 here. So we're going to be able to evaluate from when it comes from the left with this function and when it comes from the right with this function. All right, so it's going to kind of go ahead and do that. All right, so lim as f of x as x approaches 3 from the left. Once you plug in said 3 into this 3 over x minus 7, you will get negative 3 over 4. Alrighty. And then, so then when you have, and that's from the left, now lim, not leaving myself much space here, lim of f of x as approaches 3 from the right, so coming in from the red, is going to be equal to, I'm actually going to plug this one in for you guys, so 3 plus 15. 4 times 3 minus 20. Do a little bit of quick math there. And that is also going to end up equaling, oof, that should not be a plus sign. That's definitely a subtraction sign. 1 second. Subtraction. Subtraction. Let me make that very clear. This is very much so subtraction. All right, so that should be 21 minus 15, which is going to end up being 6. 12 minus 20, negative 8, which also then simplifies back down to negative 3 over 4. And this is basically the main, so as we figured out, f of x is continuous at x equals 3 because limit of f of x from the left is equal to limit of f of x with the right. Limit does exist, great. But the most important part I wanted you to just kind of realize out of this for this whole confirming continuity over an interval is this number line here. And this is kind of giving you your cute little interval that you'll be using. So yeah, thank you.